Okay, least common multiple is where we will end our chapter 1 with lesson 1.7. And so we're going to hit what is a least common multiple. And when you get done, you need to be able to find the least common multiples of 2 or more whole numbers. Okay, so first of all, a multiple. You have the definition here. The product of any number and any non-zero whole number, which means that we're not including 0, is a multiple of that number. And so, for example, and this is, I think, makes it easier, because that is a textbook definition, and a lot of people would stumble over that. And let's just do it this way. For example, 30, 40, and 50 would be multiples of 10. So 10 goes into 30, 40, and 50. Okay, so things that 10 will go into are multiples, if I'm using that as an example. Okay, so the least common multiple, and again, you have your textbook definition, the least number other than 0, that is a multiple of 2 or more given numbers. And in this particular case, the smallest number that 2 or more numbers will multiply into. So for example, the least common multiple of 6 and 10 is 30, because 30 is the smallest number that both 6 and 10 go into. And we use least common multiple a lot when we're doing fractions, or adding and subtracting fractions. We try as much as we can to find the smallest number that both our denominators will go into, and then go from there with our steps of adding or subtracting fractions. So again, we have the list method of finding least common multiples. I'm not a fan of the list method, although it does work. And for small numbers, not that big of a deal. So here's how you do the list method with LCMs. Is you simply start listing the multiples, in this case of 3, and then the multiples of 5. And the smallest thing that you run into that shows up on both lists is your least common multiple. So, okay, multiples of 3 are 3, and 6, and 9, and 12, and 15. That's a 5. It's supposed to be a 5. I'm not doing very well with 5s. 18, and so on. Now, here's the thing. The problem is you may not, in this case, I hope you already see the multiple of 5, but in a longer list, or with bigger numbers, you may not know how far to go. So you may have to go a long way making this list of when you have multiple numbers going on there. So 5, multiples of 5. You got 5. You got 10. You got 15. Oh, there it is. In this particular case, you got lucky because that's supposed to be a square. 15 happens to show up pretty quickly on both lists, and so 15 is the least common multiple. Now, like I said, bigger numbers and so on, you may have to go a long way before you find that multiple. All right. So 4, 6, and 12. All right. So let's go ahead. What's the smallest number that shows up on these lists, so that these 3 numbers go into? Well, okay. 4, 8. 4 times 2 is 8. Then 12, going up by 4s. 16. That's a 6. 18. 20. Okay, I'm going to go to I'm going to do a few out of 6. So we got 6, we got 12. Well, I got 12 that shows up on both lists, and actually I hope you realize in this case that you're going to have 12 as the first one. So in this particular case, 12 is our least common multiple. And listing works. It does work, but the problem does, like as I said, when we're talking about large numbers, listing all of the multiples of large numbers can get pretty hairy, okay? So I prefer a prime factorization method. And so here are the steps if you're going to use the prime factorization method, which is my recommendation. Use the prime factorization method. So first you need to write the prime factorization of each number, okay? Now whether you use the tree diagram or the factor trees or the step diagram, it doesn't matter to me, but you need the prime factorization. Now in this particular case here, oh that's right, I do need to do the prime factorizations of these 2 things. So 78. Let's, just for the sake of doing it in this particular case, let's step diagram this bad boy. I know 78 will divide by 2, and that will leave me 39. And 39 I know divides by 3. 39 divided by 3, that's going to be what, 13? Yeah, 39 divided by 3, yep, that is 13. Okay, and 13 is prime. So the prime factorization of 78 is 2 times 3 times 13. Okay. Now I am going to go ahead, actually no, I can do this. I'm going to change colors here though. I'll do 110 down here, and I will do the factor tree method for 10. Again, I don't care which method you use. Alright, I know that 110 is 11 times 10. 11 is prime, 10 is not, it's composite, it's 2 times 5. So my prime factorization, because these are both primes, will be 2 times 5. I'm going to try to put these in order if I can, times 11. Okay, so that's the first step. You need the prime factorization of the two numbers. In this particular case, I did so using, well, each method. So that's number 1. Step 2, let me move this out where we can say it. Identify the prime factors common to each list, or common to at least 2 or 3 of the lists. I'll show you what that means as we go ahead. So I'm going to go ahead and I'm going to identify the numbers first that fall on both lists here. I haven't used blue. I will use blue. So in this particular case, it's 2. So I'm going to pull that 2 out. Now the next step is I'm going to list the prime factors that are only shown once. So you'll notice I popped out of my screen there for a second. Let me go ahead and get this back to where it needs to be. Sometimes my views change if I pull things out in the wrong spot. So sorry about that. Zoom the entire page. Okay, that gets me a little closer. So all right. So now I need to go through and I'm going to identify the numbers that fall on only one list. So 3, 5, 11, and 13. Okay, and I'm going to bring these factors down as well. So 3, 5, 11, and 13. Now my least common multiple in this particular case is the solution to 2 times 3 times 5 times 11 times 13. Now I'm going to cheat a little bit here to take time. I'm going to multiply these out on a calculator, which I currently have picked up and have in my hands. The total is 4,000, or the product is 4,290. Now here's what I say about the list method. Would you really want to make a list of all of the multiples of 78, all of the multiples of 110, until you get to 4,290? I wouldn't, so that's why I think using this method is definitely preferable. So, okay. So we have now 3 numbers, and the first thing, step number 1, is to list the prime factorizations for each of the numbers. In order to save time, I've already done it. Here are the prime factorizations. You would just need to do those either using factor trees or step diagrams or whatever. Okay. Now, so start by identifying all of the things, the values that show up on each list. On all, in this case, 3 numbers, so numbers that show up on all 3 lists. Well, 3, that 3 is the only number that shows up on all 3 lists, so I will pull it out. Okay. Then you go, since I go to numbers that fall on 2 of the lists. So I see this 3 here is on 2 of the lists. So I'm going to pull that 3 out. I don't have any other numbers that fall on 2 of the lists, so I'm now going to identify the numbers that fall on only 1 list. 2, 3, and 5. And so you sort of work your way down from all lists to 2 lists to 1 list. So I will bring the 2, the 3, and the 5 down, and I will go ahead now and I will multiply across, or you can if you want to. That's 9. That's 15. 15 times 2, if I bring my 2 down, 15 times 2 is 30. So I now have 30 times 9, and 3 times 9 is 27, and tack on a 0, 270. So 270 is the smallest value that 6, 27, and 45 will all multiply into. Again, do you want to make a list of all of the multiples of 6 and then all of the multiples of 27 and all of the multiples of 45 until you happen to run into 270 somewhere down the road? Carla and her little brother are walking laps on a track. Carla walks 1 lap every 4 minutes, and her brother walks 1 lap every 6 minutes. They start together. In how many minutes will they be together at the starting line again? Okay, so we need to figure out what is the amount of time, the least amount of time, that will take them to walk, but then end up at the same spot at the starting line, and that is important. So I have 4 and I have 6 here, and I'm going to factor tree these things real quick, but you didn't really probably have to factor tree them. So the factorization of 2, prime factorization of 4, I should say, obviously is 2 times 2, and the prime factorization of 6 is 2 times 3. Yeah, you probably didn't have to do factor tree for those. All right, so 2 shows up on both lists, so I'll pull that 2 out. But then I have 2 and 3 that must be pulled out independently. And I just go ahead and multiply across, and that gives me my solution. So 2 times 2 is 4, 4 times 3 is 12. So after 12 minutes, or in 12 minutes, these 2 kids will be back at the starting line together. And that gets us to the end of our lesson. And so your opportunity to do some LCMs. Good luck.